The purpose of this program is to familiarize users with RFTLTS functions and procedures. Detailed information can be found in Technical Order 33A1-5-516-1. The Radio Frequency Transmission Line Test Set, AN-USM 638, is a portable transmission path tester. This frequency domain reflectometer, called RFTLTS, performs functional testing of RF paths between 10 MHz and 18 GHz with an available frequency extender to 26.5 GHz. RF paths include individual coaxial and/or waveguide transmission lines, connectors, power dividers, RF switches and splitters, and antennas. The performance of these paths can be degraded by external elements, such as moisture, hydraulic fluid, and vibration. This in turn can affect the performance of the associated prime systems, including electronic countermeasures, communications, radar, IFF, missile guidance, and SATCOM. Regular testing with RFTLTS will maximize path performance and hence the performance of the prime systems. RFTLTS tests RF transmission paths by performing insertion loss, either for a specific aircraft or in generic mode, or VSWR, voltage standing wave ratio measurements. If a problem is detected in insertion loss or VSWR, RFTLTS will isolate the fault by measuring the distance to fault, DTF. With the fault located, line repair is expedited. RFTLTS has been designed with the user in mind. It's fast, portable, and easy to use. Handheld antennas provided with the test set ensure complete analysis of RF system paths, including aircraft antennas. Testing can be performed either by direct linking the line with an RF adapter or by radiating using a handheld antenna. RFTLTS eliminates the need to remove radomes to gain access to aircraft antennas. Menus and messages guide the user through every step of the testing process. It is important to know that every brand and type of cable has unique characteristics. These characteristics affect RFTLTS' ability to determine precisely where a fault may lie in the RF path. RFTLTS uses the cable characteristics as well as the correct cable length to accurately fault diagnose the RF path under test. The system operates by transmitting and receiving measured RF signals. For insertion loss testing, an RF signal is transmitted at a range of frequencies from the RFTLTS through the path being tested. The insertion loss probe receives the RF signal, converts it to log video, and passes the log video data back to RFTLTS. RFTLTS then processes the information to determine insertion loss values. For VSWR testing, the RF signal is transmitted through the VSWR probe into the path. The return from the path is measured and converted in the probe. The data is then transmitted to RFTLTS through the video cable. For distance to fault, RFTLTS sends a ramped frequency through the line centered around the frequency identified as the problem. It then receives signal energy reflected back from the fault. By measuring the reflected signal, RFTLTS can determine the location of the fault. RFTLTS is delivered in two ruggedized transit cases. One contains the RFTLTS test set, and the other contains its accessories. The test set is fastened to the base of its storage case. To open the case, turn the 6 fasteners counterclockwise to unlock. The cover then lifts off. The RFTLTS system is made up of 6 modules, 2 external, the display and keyboard, and 4 internal. The power supply, the stimulus module, the analog measurement assembly, and the test set processor. The display is a sunlight-readable graphic screen. The keyboard has enter and delete keys, arrow keys for moving around the menus, and alphanumeric keys, which work in conjunction with select keys. The enter key is used at the menus to select an action. The delete key works as a backspace, deleting one character at a time. Each alphanumeric key has a number and 3 letters on it. The numbers are active unless a select key is used. If select 1 is pressed along with a number key, the left letter is typed. Using select 2 will activate the middle letter, and using select 3 will activate the right-hand letter. Certain keystrokes have been set up to perform particular tasks. For example, pressing the Select 1 key and using the up and down arrows will adjust the brightness of the display. A soft boot can be performed by simultaneously pressing Select 1, Select 3, and the right arrow. The TO contains a list of these keyboard actions. External features include the elapsed time indicator, grounding point, and two connectors, RS-232 and IEEE 488. The RS-232 connector is used for data transfer. This includes printing test data, loading a database for aircraft-specific testing, uploading data, or reloading system software. The IEEE 488 connector is used for system calibration and alignment on a Paytech machine. At the back of the riftlets is the power on-off switch, which doubles as a circuit breaker to protect the system from overcurrent, the J1 input for video cable, J5 RF output, and a connector for AC power. Riftlets operates from 115 volt or 230 volt single phase, 50, 60, or 400 hertz power. It is important to know what the available power is and to use the appropriate cable. The riflet's top cover can easily be taken off by removing 5 screws. Inside are the 4 internal modules. The stimulus reference signal generator assembly, called the stimulus module, produces the RF energy for the tests. The response function is managed by the analog measurement assembly, which receives the signal converted by the probe and handles the measurement processing. Controlling the riflet system is the test set processor. Its functions include providing the operator interface by coordinating keyboard and display data, controlling the operation of the stimulus and response modules, and serving as the system's memory, storing operating software, aircraft databases, and sweep data. The power supply generates and distributes DC power for system operation. Both the power supply and the test set processor cards have indicator lights for troubleshooting. The TO contains a fault isolation matrix which incorporates 5 indicators: the 2 lights, the display, the elapsed time indicator, and the fan. If a light is not on, follow the instructions in the TO to correct the problem. The system fan controls the heat level inside the case, which is critical for accurate test results. The assembly is designed so the fan provides proper airflow with the cover on. Do not operate riftlets with the cover off, because the system could overheat. The accessory case uses the same type of fasteners as the test set case. Turn them counterclockwise to unlock the case. The accessory case comes with everything needed to use riftlets. 2 probes are included for insertion loss and VISWAR testing. 4 antennas are provided to cover the RF frequency range. The green right-hand circular polarized and red left-hand circular polarized antennas both cover 2 to 18 gigahertz. The low band covers 10 to 500 megahertz, and high band covers 500 megahertz to 2 gigahertz. Other accessories include a handle which can be attached to the blade antenna for radiating testing, adapters, connectors, 110 and 220 volt power cables, 15-foot and 105-foot video test cables, and 25-foot RF cables. The insertion loss probe contains a temperature-stabilized RF detector, which receives RF from the path being tested, converts it to log video, then sends the log video to riftlets, where it is digitized and stored. The VISWAR probe transfers an RF signal from riftlets to the path being tested, and then measures the return of the reflected RF energy. Probes must be attached to riftlets with the system power off. The internal crystal detectors are sensitive to power surges. Installing or removing a probe with the power on could damage the detectors. Before riftlets is turned on, it must be grounded. The ground strap protects the technician from electrical shock and prevents damage to riftlets. Attach the ground strap to the aircraft if it is grounded. If not, use an earth ground. Attach the other end of the ground strap to the grounding point on the side of the unit. Next, the system must be connected to a power source. Determine what power will be used and select the proper power cable. Attach it to the connector on the rear of the test set. If either insertion loss or VISWAR is to be performed, attach the appropriate probe to J1 while the system power is off. Turn the power switch on. The screen will show a checkerboard pattern while the system performs an initial self-test and internal calibration. Then the messages stimulus off temp, followed by stand by, will be displayed for the warm-up period, which depends on the ambient temperature. If the checkerboard pattern does not disappear, use the troubleshooting procedures in the TO. It is important to know that the test set may be turned off at any time. Turning it off will not affect its operating software. The only consequence will be the loss of any unstored test data. Once the system has reached its operating temperature, a warning message is displayed. Press Enter to proceed, and the main menu appears on the screen. To select a procedure, use the arrow keys to highlight the appropriate procedure, and then press the Enter key to make the selection. The following review of test procedures will assume successful completion of each step. If for any reason a step is unsuccessful, refer to the TO for corrective action. Selecting the first menu item, Aircraft-Specific Testing, begins the Aircraft-Specific Insertion Loss Test procedure. The insertion loss test measures loss of RF signal as it passes through the cable from its generation at riflets to its receipt at the probe. The loss is measured over a range of frequencies and is plotted as insertion loss versus frequency. Riflets compares these insertion loss measurements with what should be expected for the selected aircraft and path, and provides a pass or fail response. If the line fails, the distance default test is an option in this menu. The insertion loss test requires using the insertion loss probe. Remember that the probe must be installed with the system power off. If it is not already attached, turn the test set off, connect the insertion loss probe to J1, then power up riflets again. Before beginning the test, the probe must be self-aligned to zero out the probe and test cable. The hookup message directs the user to connect the RF cable, TNC to TNC adapter, probe, and video cable. Riflets will then go through a series of menus to determine the airframe, system, and path to be tested. When the setup has been completed, press Enter. This begins the self-alignment process, which takes several minutes. At the end of self-alignment, Riflets makes a clacking noise. This is normal internal self-alignment, not the sign of a problem. The insertion loss probe needs to be aligned only once per test period, accomplishing both aircraft-specific and generic insertion loss testing. Alignment is maintained until the test set is turned off. With the probe aligned, the appropriate antenna and/or cables must be hooked up to the aircraft path to be tested. Output hookup to J5 is listed on the left, and input hookup to J1 is listed on the right. The hookup requirements are based on the setup that was used to collect the sweeps for the database. The next screen is the test control menu. In aircraft-specific mode, most parameters have been set in the database. Options include altering test parameters, choosing a different RF path or system, and selecting either single or continuous sweep mode. Once these parameters have been determined, highlight Start Test and press Enter. Riflets then displays a graph with frequency plotted on the x-axis and insertion loss plotted on the y-axis. The limit lines for an acceptable test are displayed. To the right is the control menu. If the RF sweep is not visible, selecting Auto Center will bring it into view. To get a finer screen resolution, highlight dB per division and press Enter. A box with choices will appear, with lower numbers providing finer resolution. Highlight a number and press Enter. If necessary, select Auto Center again. Once the display presentation is satisfactory, select Hold Plot. If the sweep is within the limit lines, the RF path is within the acceptable range. The Results Control menu allows the user to change the display parameters, print the sweep, or store the sweep. Select Test Complete. Options then include selecting another path or another system. Path selection displays a list of paths, with an asterisk denoting paths that have been tested during this session. If the RF path sweep is outside the limit lines, Riflets will box all points that fail. Riflets displays a list of numbered failures in descending order based on magnitude of the bandwidth, with corresponding frequency and bandwidth. If there were multiple faults, the user has the option of selecting, by number, which fault to perform the DTF test on. The system default is to test the largest fault first. To view a particular point along the RF sweep with a finer resolution, select Move Plot Cursor from the Display Control menu. The cursor, which appears as a vertical line, can then be moved to the point of interest. Select Expanded Scale to choose a magnified view. When a failure is detected, the Fault Isolate choice in the Results Control menu provides the option of conducting the distance to fault test to locate the failed point or points. For DTF, Riflets defaults to the worst fault. If a different fault is to be tested, remember the number of the fault and designate that fault at the Select Test Parameters menu after self-alignment. The distance to fault test involves injecting a frequency ramping RF signal into the RF transmission path. A fault in the path causes some of the injected signal to be reflected back to Riflets through the RF cable. The frequency difference between injected and reflected signals is directly proportional to the distance from the injection point to the fault. This is displayed with distance on the x-axis and the reflection of the signal on the y-axis. In most cases, the section to be tested cannot contain switches, couplers, attenuators, or other microwave components. However, feed-through connectors and adapters are allowed. The first step is to self-align Riflets and the RF cable. Follow hookup message to connect the RF cable to J5. Make sure the insertion loss probe is disconnected from the RF cable to avoid failing the alignment. Self-alignment will take 3 to 10 minutes. Once self-alignment has been completed, the test control menu will appear. Begin by attaching the cable to be tested to the RF cable connected for self-alignment. For distance to fault, the path characteristics must be set up. These include where the RF cable from Riflets will be hooked up and the cable length, cable type, and segment order. Selecting the Test Parameters menu displays the center frequency and bandwidth of the fault, determined by the insertion loss test. Select Section Composition. The RF path characteristics are displayed. For segment order, select Forward or Reverse. This identifies the RF cable hookup to Riflets. Forward sets Riflets hookup to cable segment 1. Reverse sets the hookup to the last cable listed in the section composition. Select Start Test. A graph appears on the display, with the continuous sweep control menu to the right. The graph plots distance on the x-axis and fault magnitude on the y-axis. Once the sweep has been plotted, select Auto Center and Hold Plot. The distance to the fault will be identified with a cursor and displayed in the bottom right corner of the graph. The Results Control menu appears, offering the options of Resweep, Sweep Mode, Display Control menu, Print Current Plot, Store Current Plot, and Test Complete, which brings up the Test Control menu. When Recall Test Results is selected, choices available include viewing sweeps previously saved or deleting all saved sweeps. When a sweep is selected, the Results Control menu appears. This menu provides the choices of deleting a single sweep, printing the selected sweep, or going to the Display Control menu to alter the display parameters of the selected sweep. If the list of sweeps is longer than can be displayed on the screen, highlighting Next Page and Previous Page will move the list of sweeps. The Insertion Loss Test choice at the main menu selects Generic Insertion Loss. The purpose of generic testing is to test paths not included in the aircraft-specific database. As with aircraft-specific insertion loss testing, the lines can be swept either by connecting directly to the cable or through antenna couplers for radiating measurements. Before beginning the test, the probe must be self-aligned to zero out the probe and test cable. If the insertion loss probe has been aligned since Riflets was turned on for this test period, it is not necessary to align the probe again. The hookup message directs the user to connect the RF cable, TNC to TNC adapter, probe, and video cable. When the setup has been completed, press Enter. This begins the self-alignment process, which takes several minutes. At the end of self-alignment, Riflets makes a clacking noise. This is normal internal self-alignment, not the sign of a problem. Confirm that the probe's input hookup is correct. If it is not, turn the system off to connect the probe. Connect the output hookup as directed. Press Enter. Unlike aircraft-specific insertion loss, which has an established database for path characteristics, generic insertion loss tests require that test parameters be set up. At the Test Control menu, selecting Test Parameters allows the operator to set the start and stop frequencies, sweep resolution, output power, and sweep sensitivity. Once all the parameters have been set, select Start Test. The display is an XY plot of insertion loss versus frequency, with frequency on the horizontal or X axis. Immediately, an XY graph will appear with a continuous sweep control menu on the right. The sweep will be plotted across the graph. First, select Auto Center to center the plot on the graph. The dB per division can be changed to increase resolution. If this change moves the plot significantly, select Auto Center again to center the plot. Once the sweep display has been set, allow a full sweep to be completed. Then select Hold Plot. When a plot is held, the Results Control menu appears. Options include changing the sweep mode, storing the plot, printing the plot, and a menu to make changes to the display. The Display Control menu provides the usual choices of normalized results: dB per division, reference, limit lines, and Auto Center. Additional choices included at this point are Move Plot Cursor and Expanded Scale. The vertical line is the cursor. A box is displayed identifying the frequency and insertion loss at its location. Moving the cursor to a point that is suspicious enables the user to determine the frequency and loss of the fault. The expanded scale allows a magnified view of a segment of the sweep. When a sweep is to be stored, a form appears on the screen to provide the needed information for the sweep. In generic mode, the aircraft, system, and path information should be entered. Selecting Distance to Fault from the main menu provides generic distance to fault testing for fault isolation. Distance to fault tests are performed when a fault is suspected as a result of unacceptable insertion loss or VISWAR measurement results. In most cases, the section to be tested cannot contain switches, couplers, attenuators, or other microwave components. However, feed-through connectors and adapters are allowed. As with aircraft-specific DTF, the first step is to self-align the cable. Once DTF is selected, the self-alignment hookup message appears, requesting that an RF cable be attached to J5. Make sure no probes or other cables are attached to the RF cable during this process. Self-alignment will take 3 to 10 minutes. Once self-alignment has been completed, the Test Control menu will appear. Begin by attaching the cable to be tested to the RF cable connected for self-alignment. The Test Parameters menu provides a section composition choice. Section composition requests information on the number of cable segments, the length of each segment, and the type of cable to be used, selected from a library of cable types. It is very important that the cable lengths, segments, and cable types be accurately entered to ensure reliable distance to the fault measurement. Other options include setting the center frequency and the bandwidth. If problem frequencies and bandwidths were identified during insertion loss, that information should be used with this menu, enabling the user to select which fault to troubleshoot. Set bandwidth as wide as possible to obtain the best resolution. However, do not set it to sweep more than one fault. Once these parameters have been set, select Start Test. A graph appears on the display, with the continuous sweep control menu to the right. The graph plots distance on the x-axis and fault magnitude on the y-axis. Once the sweep has been plotted, select Auto Center and Hold Plot. The distance to the fault will be identified with a cursor and displayed in the bottom right corner of the graph. The Results Control menu appears, offering the options of Resweep, Sweep Mode, Display Control menu, Print Current Plot, Store Current Plot, and Test Complete, which brings up the DTF main menu. Riflets performs generic VISWAR return loss measurement. VISWAR, or voltage standing wave ratio, is a measure of how much signal is reflected from the part being tested. Results are given as a ratio of emitted signal to return signal. Alternately, the results can be shown as return loss, which is the inverse of VISWAR. The display is an XY plot of VISWAR, or return loss, as selected by the operator, versus frequency, with frequency on the horizontal axis. As with the other tests, probe self-alignment is the first step. The probe must be connected with the system off. The hookup messages request that, for output, the RF cable be connected to J5. On the input side, attach the appropriate video cable to J1. Follow the screen message to screw the calibrated short connector to the VISWAR probe. Press Enter to begin calibration. After a minute or so, a message appears requesting that the calibrated short be removed. Press Enter to continue the self-alignment process. Once self-alignment of the probe has been completed, the Test Control menu appears. Attach the part to be tested to the appropriate RF adapter. Then, make sure that the path to be tested is properly terminated. As before, the test parameters, display parameters, and sweep mode can be set from this menu. From the Test Parameters menu, the start and stop frequencies and the sweep resolution can be set. Then, select Start Test. If the sweep is not visible, select Auto Center. Select Hold Plot. At the Results Control menu, options available include Resweep, Sweep Mode, Display Control menu, Print, Store Plot, and Test Complete. At the Display Control menu, the plot cursor can be moved to allow operator control of on-screen cursor. The X-Y coordinates appear in a box indicating frequency, X, and dB return loss, VISWAR, Y. The display mode can be set to show return loss or VISWAR. At any time, the operator can select a lower dB per division for finer sweep resolution. An alternative to the Auto Center feature is to adjust the dB Y-axis scale by choosing a new value for the upper reference point. The limit line selection at the Display Control menu allows the operator to set the lower limit line. After turning the limit line on, select Resweep and then Hold Plot. When a sweep exceeds the limit line, the points are boxed, annotated, and available for distance default testing. To view the failed points, return to the Display Control menu to move the cursor to a point of failure. Selecting Expanded Scale allows magnification ×1, ×2, or ×5 of the cursor position. The plot can then be stored or printed. The Self-Test menu provides three options: Resource Status Display, Resource Diagnostics, and Confidence Test. The Resource Status Display provides an overview of the status of the hardware and software associated with Riflets. It also lists the version of each software element and database. The Resource Diagnostics allows the operator to test each of the system elements. Self-alignment is used to test both the VISWAR and insertion loss probes. Sweep probe tests only the insertion loss probe. The antenna test performs self-test on the accessory antennas. VISWAR can be checked on both of the spiral antennas, right and left-hand circular polarized, as well as on the high-frequency blade antenna. Insertion loss can be checked on the low-frequency blade antenna. The manual choice allows the operator to select a manual sweep of Riflets in either digital or analog mode. Refer to the TO for further information. The confidence test is simply a soft boot of the system. Riflets is maintained at the O level and I level by performing self-test on a scheduled basis. Self-test is augmented by fault isolation procedures. Refer to calibration TO 33K9-4-29-1. Data transfer can involve importing an aircraft-specific database to Riflets or exporting sweeps to an AN GYQ59 or IBM-compatible computer, loaded with the appropriate transfer utility. The first step is to select the computer to be accessed. From the Configuration Selection menu, select Data Transfer. Hookup messages are displayed. Transferring data between riflets and another machine involves using the RS-232 port on the side of the test set. When the hookup has been completed, the menu options are to send sweep data or to receive data code. It is important to remember that the receiving station must be set up first. If the sending station is set up first, the system won't know where to send the data. Follow display messages to complete the data transfer. This completes the overview of Riflet's test procedures. For more information, consult TO 33A1-5-516-1 for procedure and schematics. TO 33K9-4-29-1 for calibration, and TO 33A1-5-516-4 for parts breakdown.